And the basilar membrane is within the cochlea of the ear that contains the hair cells. And the hair cells are sensory receptors used for sound. So this is what it kind of looks like. Imagine if you have a super tiny little guy jackhammering right next to your ear. The sound enters the pinna right here, right? Here's the cartilage, all that kind of stuff. Goes into the ear canal, hits the eardrum. All right, then it is vibrating through these little bones. The middle ear contains a chain of 3 tiny bones called the ossicles. So again, the hammer, the stirrup, and oh my gosh, just blanked. The hammer, the stirrup, and the anvil. Oh my gosh. All right, and then it enters the cinnamon bun-looking thing, which is the cochlea. And inside this is the basilar membrane that has the hair cells right here. Okay? Hair cells within the cochlea of the inner ear respond to vibrations by generating nerve electrical impulses. The brain interprets these as sound. These little guys right here, these are called the semicircular canals. And those are actually for balance and equilibrium where your head is in space. We'll talk about that later on. All right, types of deafness. The tiny bones of the middle ear are damaged or become brittle, as they sometimes do in old age. Conduction deafness may result. Conduction deafness can be helped by a hearing aid, which amplifies sounds. You can see this a lot. All right, conduction deafness is pretty prevalent, especially in old age. Damage to the hair cells or auditory nerve can result in nerve deafness, which cannot be helped by a hearing aid. Exposure to loud noises can cause nerve deafness. There's a thing out there called the cochlear implant, and that's wherever you can get an implant to replace the cochlea, and actually people can hear for the first time ever because of that. All right, basilar membrane is the key structure to distinguishing pitch. We have 2 theories, the frequency theory and the place theory. I've never seen this on the AP exam, doesn't mean that it won't be there. Frequency theory, the view that the basilar membrane vibrates at the same frequency as the sound wave, which would be interesting because the sound wave comes in, it has to hit eardrum, the ossicles, the 3 tiny bones, and then it gets into the cochlea, and then it gets into the basilar membrane. Okay. Then place theory, the view that the different frequencies cause larger vibrations at different locations along the basilar membrane. Both of these theories are just theories, but they explain the processing of hearing on different levels. All right, we done. Next time we're going to hit up chemical and body senses.